I love this question because it actually pushed back a little on it increasing cost. You're right in that it increases hardware, but depending on what people have done beforehand, it doesn't necessarily increase their cost. And what I'm kind of getting at, and you kind of talked about it in the cloud, is originally without distributed validators, the real problem was that there was more or less no safe way to run a backup. The only kind of option you had was do some sort of monitoring game and pray that your monitoring is, perfectly reliable, and there's not a scenario where you turn on two machines with the same private key at the same time. And the problem with not being able to run a backup is it can be very hard to recover from a failure. Particularly if you want to use something like a bare metal machine in like a data center somewhere, that's usually one of the more low cost ways to run a server. And the problem is if you do put, particularly a large amount of private keys on a bare metal server like that, and it just goes offline, which is regular occurrence, will probably happen at least once or twice a year. You just kind of have to sit in your hands. There's more or less nothing safe you can do at that point. You can try and bring up a backup and hope to shut down the backup before the primary comes back, or you can ring up the data center and ask them to kind of go and like pull the plug out the wall. But this not being able to like run a backup has changed a lot how people have, built their architectures in the early years. Most of these centralized, I say most, that's not quite true. A lot of centralized providers at least started running in the cloud, particularly because then if you do have a failure of your machine, you can kind of detach the disk. It's all in software. You have a lot of power to kind of actually recover things that you don't have when it's just a server sitting somewhere. But the problem with that, and you kind of alluded to the fact that they might run one machine, a lot of people, they'll have at least a few servers in the cloud. Normally they'll have kind of at least two that runs kind of ELs and CLs, which is kind of the meat of it. Then they'll have a machine with their validator on it, and plausibly they'll have some more with a key manager on it as well. So a lot of people, like kind of enterprise staking validators, you're talking kind of 3 to 7 cloud servers. And cloud servers are much more expensive than a bare metal server. Rule of thumb, think about 10x more, including one of the real kickers is bandwidth costs, which I'm sure you guys are familiar with egress, but that can often take up 30% of the kind of operating cost of a cloud validator. So you start to pile on egress, multiple cloud machines, and so on, and it really starts to end up kind of costly. And that's kind of one way to have, high uptime without distributed validators, is to kind of put it all in the cloud, have a bit of failover and do things that way. The other option that some routes go down is they kind of do the hardware route, where they'll buy a particular server that has dual CPU sockets. So they have 2 CPUs, they have a RAID array of disks. So if even one disk fails, no problem. They'll have dual networking cards. So, if there's problems there, they'll survive, maybe dual PSUs. But these PCs cost in the tens of thousands of dollars, and they're not particularly cheap. So either, trying to get kind of fault tolerance by using cloud services, or fault tolerance by using really expensive hardware. Both of these are, not as cheap as you expect. A lot of, some of these stacks, if you're running 7 machines in the cloud, you wouldn't feel spending a couple thousand, maybe 3,000-4,000 a month for something like that. And if you then have distributed validators, and you can have private keys like split into groups, it opens up the ability to more safely put validators on bare metal machines, because if one of your 4 machines dies, no big problem. It'll stay online. You can kind of wait for it to come back. If it doesn't come back, you can bring up another, partial on another node. It's not going to cause a slashing. It doesn't have a full key on its own. All of these machines are doing consensus beforehand. So kind of what we talk to a lot of these centralized providers that are like, how could, distributed validators possibly not increase my cost? We tell them that, with software fault tolerance, you can move away from like cloud-based solutions. You can move away from having like extremely, fancy hardware-based solutions to have high uptime. And instead you can move towards commodity bare metal and use just fault tolerance to do it. So instead of having, 4 to 7, $400 a month nodes that run in the cloud, you can have, $100 a month bare metal machines, and your full stack can cost $400 a month instead of $4K a month. And yeah, the last kicker of that is, can you do it at scale with high load? And we're, running a lot of good tests in that regard, seeing if we can do this at like, thousands of keys as well to improve margins. But yeah, naively in the scenario, yes, you're running more than one node, but bar the home staker, most enterprises, most, operators within the LSPs, they're not running a single machine unless they're, doing something with very fancy hardware. They're probably running at least a few machines. So distributed validators and having fault tolerance allows them to kind of, use cheaper servers, less, not over provision them as much. And we're reasonably comfortable, bar, the people that are already running on bare metal have a very low cost basis. There's a very large amount of validator operators that we speak to that DVT actually will let them reduce their costs, even if they are running more hardware.